So, what are the basic concepts of probability? Well, let's look at an example. In fact, let's look at two examples. So, straight away, let's bring on these two examples. We've got a spinner here. Not a very good drawing, but I think you'll get the idea. A spinner, which is a fair spinner. Okay, so that means it's equally likely to land on 1, 2, 3, 4, or 5 after we've spun it. And here we've got a bag. Again, this is a random selection of these marbles, so it's equally likely that we're going to pick, well, a yellow, or this blue, or this blue, or this red, or this red. So we're dealing with fives here. Now, what's the basic concept of probability? What's the basic idea that we use? Well, we think of it basically in terms of a fraction. So if I think of my number line, for example, let's just draw a quick number line at the top here. And if we have 0 on our number line here, and let's say this is -1, and this is 1, and this is 2, and of course it goes forward and backward into the negative and up into the positive, then probability only deals with this area here. Okay? In other words, it's only ever a fraction. And let's see why that's the case. Now, if I said, well, what is the probability with my spinner, for example, of getting a 6? Probability of getting a 6. Okay? So we write it like this. Probability, and the event is this bit in brackets. So the event of getting a 6. Probability of the event which is getting a 6. Well then, the answer to that would have to be there are no 6's on this spinner, so the answer is 0 probability. And it's 0 out of 5 possibilities, so we say it's 0 out of 5. And that fraction, if you can call it a fraction, is obviously 0 out of 5, 0 divided by 5, in other words, which is simply 0. And we can express all our probabilities as either a fraction or a decimal or as a percentage. So you should be familiar with just converting between them very easily. So this can be expressed as 0%. That there's a 0% probability of getting a 6 because, of course, it's impossible. Okay? It's impossible that I will get a 6. So that's here on our number line, 0. And there's nothing in probability, anyway, less than 0. You can't have a negative probability. It's either impossible or it's certain. So that's here. So we have 1 representing certainty and 0 representing impossibility. And then, of course, we have all these shades in between, which are fractions. Okay? So, say, for example, we said the probability of spinning a 1, 2, 3, 4, or 5. So, probability of the spinner landing on 1, 2, 3, 4, or 5. Well, obviously, each one of those is a 1 in 5 possibility. There are 5 of those, so it's 5 out of 5. Which is a certainty. It will land on either 1, 2, 3, 4, or 5. Okay, so 5 out of 5 is 100%. And we call that a certainty. It's certain that it will land on 1, 2, 3, 4, or 5. So usually what we're trying to do in a probability question is get this figure, either a fraction or a percentage or a decimal. So in this case, the decimal answer would be 1. Okay, 100% is 100 out of 100, 5 out of 5, 5 divided by 5 equals 1. So everything between 0 and 1. So let's try a fraction this time. What if we said the probability of our spinner landing on a number greater than 3, let's say. Okay, probability of landing on a number greater than 3. Well, that's going to be the probability of it landing on 4 or 5. And there are two probabilities then, two possibilities, two possible outcomes. 4 or 5, that's 2/5 of our spinner. And so we simply write it as 2/5. We've got two equally probable outcomes, so 4 and 5, 1, 2 and 3, they're all exactly the same area here, so exactly the same chance of landing on them. So we've got a 2 out of 5 possible outcomes, giving us 2/5. What's that going to be? Well, if I multiply it by 20, that will give me 40%. Okay, 40 out of 100 is 40%. Or, if you want to express it as a decimal, 0.4 is our answer. Okay, what about the bag then? Well, bag examples are much the same. We call this a population. So even though it's population, even though it's things, we still call them populations. You can say collections of things, but collections are population. Population of 5 things in this bag, which of course wouldn't be transparent, otherwise it wouldn't be a random selection. And so what have we got? Let's ask for the probability of getting blue. Okay, so probability of getting blue, there are 2 blues out of 5 possibilities. So again, we've got 0.4 or 40%. So pretty straightforward so far. Let's do one more. Let's say the probability of getting red or blue. And that's going to be 4, because we're talking about 4 objects, if you like, 4 counters out of our population of 5, so it's going to be 4 out of 5. Very obvious. The only thing to note here, though, is that we've got this OR. And when we've got this sort of thing, we're usually thinking about splitting it into 2 events. So what I'm going to do is just write this out in a slightly different way and say we could rewrite this, the probability of red or the probability of blue. And this we call compound probability, when we've got 2 things that we've lumped together, if you like, into what seems to be 1 event, but it's actually 2 events, we could say. So we've got a red or a blue, and that means we can split it up. So we've got a 2/5 probability of it being red and a 2/5 probability of it being blue. Now there's no point here in this example, because this is a trivial example, but in some more complex examples, splitting it up like this is going to make the problem a lot clearer. So 4/5, or if we multiply by 20, so we've got 80%. So finally, just to round up a few of the ideas that we've been working with in the first part of the video. First of all, a probability fraction is the general formula, if you like, for a probability fraction is desirable or favourable outcomes over all possible outcomes. So here we had the probability of rolling a 6, rolling 6, then our fraction is going to be made up from the number of desirable outcomes, or the number of desirable outcomes. If we just need to roll a 6, there's only 1 6. So because there's only 1 6, then 1 goes in the numerator. So number of desirable or favourable outcomes is 1. And then the idea of the denominator, the number underneath, is to write down all the possible outcomes. And on our dice there are 6 possible outcomes, so it's 1 in 6, or 1/6 probability. So it's important that you understand this general formula. The other term you might find used here for all possible outcomes, when we're actually looking at all the possible outcomes and laying them out, perhaps putting them in a grid, for example, and saying, well, what are all the possible outcomes that we could get? then we use the term sample space. So the sample space is literally all the possible outcomes, often displayed visually. And the number of desirable outcomes is sometimes written as number of favorable outcomes, but it means pretty much the same thing. So it's the number of things that we want. So how many things do we want? That will be in the event here. So the brackets contain the event that we're asking about. So important concept is the concept of an event. There's quite a lot of terminology when you're starting out in probability, and it's very important that you understand these things accurately. So the probability of the event of rolling a 6. Now if we think of another event of rolling, for example, more than 3, so we've got 2 events here now, and we might think of these, we might label these event A. So it's very common to label our events, event A and event B. We can then make statements about event A and event B without writing out this event, all the words inside the brackets here. So you might get this kind of notation here. Now one final concept that's very important for you to grasp, which is the idea of mutually exclusive events. Now what does that mean, mutually exclusive? Well, basically it means overlapping. So if I draw a diagram down here of, which is basically a Venn diagram, if you've come across Venn diagrams before, this can represent event A, and there's only one there's only one favourable outcome rather. There's only one favourable outcome. So I'm going to represent that by a dot. So there's only one favourable outcome. So the number of favourable outcomes or desirable outcomes for event A is just 1. Now what about event B? Well, more than 3 means 4, 5 or 6. So 4, 5 or 6 means there are 3, but one of them is event A. So these things overlap. So if this is rolling a 6, so let's actually write 6 here. So that's rolling a 6. Event B will be rolling a 6 or rolling a 5 or rolling a 4. So 4, 5 or 6. So if I draw the set that represents event B, I would have to draw it all the way around like this, event A. Okay? And that's what we mean by overlapping. That event A is overlapping entirely with the larger set, event B. So what we can say is these are not mutually exclusive. If I am looking at this event here, rolling a 6, then I could also be rolling more than 3. So they're not cancelling each other out. If that happens, that could also happen. And that's what we mean by overlapping. They're overlapping events. Now, what I am going to do now is change this to events which are not overlapping. Okay? And I'm simply going to change it by altering this word here. So I'm going to alter one of the events so that they're no longer overlapping. Okay, let's do that. So if I erase this now and replace it with, so we had more than 3, we're going to have now less than 3. Less than 3. Clearly what that means is less than 3 is 1 or 2, so we've got the probability now of rolling 1, just put 1 or 2. And what would be the fraction that we would get for that? Well, there's 2 chances of rolling then a 1 or a 2. So it's 2 chances out of 6. So number of desirable outcomes or favourable outcomes is 2. And the denominator is still 6 out of 6. So what I've done is created mutually exclusive events. What do I mean by that? In fact, let's just write that down very clearly so you can get this concept very clear in your mind. So mutually, these are now mutually exclusive. And all it means is that if I roll a 6, then I can't have rolled less than 3. So that cancels this one out. If I roll a 6, then I definitely didn't roll less than 3. Equally, if I rolled less than 3, then I didn't roll a 6. That's what we mean by mutually exclusive. And again, we can use Venn diagrams to express this. So we can show this concept, mutually exclusive, in a Venn diagram, which I'll draw over here. So if I draw event A, again, so this is event A, and this is the event that I roll a 6, then I'm going to roll, for event B, I'm only going to roll a 1 or a 2, and I'm going to draw this over here. So event B is a 1 or a 2. No overlap, they're mutually exclusive, so I'll represent this as a non-overlapping event, like that. So all that mutually exclusive means is not overlapping. So if you think of those Venn diagrams, think of, is it overlapping or not? So if you're asked, is it mutually exclusive? If it's not overlapping, and they're not overlapping anymore, then it's going to be mutually exclusive. So you can say these are mutually exclusive events. The one cancels the other. Okay, so that's a little summary and a few concepts there for you to get your head round before you go on to the next video. But hopefully those concepts are clear before you tackle more complicated problems. Okay.